So welcome to your Shoreham beach practical. So Shoreham is just to the west of Brighton. See Brighton over there in the distance, yeah, just over there by those chalk cliffs. And what you've got basically between Brighton and then all the way along the bulk of the Sussex coast is you've got this shingle type beach. Now in this set part of the coastline this is really quite common. However, as a sort of European wide scale, shingle beaches are rare and they're also considered to be a protected habitat. So in the EU Habitats Directive these are considered to be protected, and the reason they're considered to be protected is that they support a range of different species. Particularly you can see here the sort of, it looks like it's dead and dying, but it's because we're getting towards winter now. You can see this sea kale. You've got a range of different shingle beach vegetation up here, and this is actually quite rare from a European scale and therefore from a sort of international scale. Now this is in this upper section, yeah, this protected vegetation. Okay, then you go down the beach and you can see that actually along the rest of the beach there's a section where you've got this these maiden's tresses, or devil shillis, it's called corda phyllum, that's been washed up, this macroalgae. Yeah, beyond that, which is the upper intertidal area, all the way down to where the water is at the moment at low tide, you've actually got nothing living in there, or no sort of plant species. Yeah. The reason for that is this is a highly dynamic environment. So this is the low tide, yeah, this is the lower intertidal there where the water is, and the water comes up to here. This is inundated 2 times every day. Okay, we've got about 7 metre tide at the moment, so we've got the equinoctial spring tides, yeah, so that goes about 7 metres down to 0 metres, which is chart data down there at the bottom. Now where the water is there, tide's just starting to come in. We're going to be seeing that there's some sands down there, and that extends out for a fair distance actually, for about 150 metres. Okay, now in that section there's also patches of shingle there in the lower sort of subtidal, and that's where you start, that's continuously covered, that's where you start getting a bit more life again. So there you got like snakelocks anemones, beadlet anemones, you've got a wide range of macroalgae. This time, this year we've got actually a massive bloom of this corda phyllum, it's made its tresses. We've got a little bit of saccharina, the sugar kelp, a little bit of laminaria, another type of kelp, and then we've got a range of different rhodophytes and chlorophytes there. Okay, so we've got quite a lot of life there in that lower subtidal, quite a lot of varied protected species here in the supratidal, so that's that bit that's above the highest astronomical tide. But in this really dynamic part of the beach that's inundated sort of a couple of times a day, and that's where you got your main wave activity, you actually not got very much living there at all. So here we've actually got one of the most biodiverse areas in the Sussex coast. Okay, now in that subtidal area around here, you've got a wide range of species that utilise those subtidal habitats. So you got ungulate rays, you get some blonde rays, you get small spotted cat sharks, there's cuttlefish, there's squid there, common European squid and the European squid. You've also got a range of other species that come in to use the area, such as bass. You've got, so these are the commercially important ones, you've got bass, you've got cod, you've got poor cod, you've got pollock that come in there, you've got black sea bream. Okay, and also you've got some really rare species, so things more like butterfish, you've also got seahorses, you've got pipefish. All of those are sort of those latter ones are protected species for this area. Okay, so it's actually really quite an important area, this Shoreham beach patch here. As you can see, we've got different sediment here. You've got the fine sands, yeah, which is the bulk of it in this lower intertidal area, and then you've got some gravel and pebbles over this side, yeah, and then as we look up the profile of the beach, you can see starts to get coarser sediments, and as you go up you've got more boulders, cobbles, a lot more gravel and a lot less sand going up the beach. So it's quite important to evaluate what the changes in the sediments are, because they can tell you about what kind of energy and what kind of factors are influencing the geomorphology of the beach. So what we're going to do is we're going to be assessing how the sediment changes at different points of the beach. We'll do one in the lower intertidal just down here, and we'll collect a set of sediment from the ground there. We will put it into the sieves and we'll work out what the sediment, the granulometry is here. Then we'll see how it is a little bit further up, and then we'll see how it is right up the top. Because obviously in this section of the beach, this is predominantly covered by water. We're at low tide at the moment, so you can see there's just this little bit of sand that's uncovered. That goes out for about 150 yards out to sea. Okay, so this bit right up the top that you can see up there, where there's some macroalgae deposited, that section is very rarely covered. In actual fact, it's only covered by the highest of the high spring tides, such as we've got at the moment. We've got equinoctial spring tides at the moment. So here we've collected a fist-sized amount of sediment from the lower intertidal section here. As you can see, the bulk of it is actually made up of sand, with quite a lot of gravel, particularly in this sort of subsurface layer. What we're going to do now is we're going to take this sediment here, we're going to place it on some in the sieves, and then we're going to shake it and work out what the percentage of each size fraction is by weight, and we'll weigh it here on the beach. Okay, so here we've got this sediment, and these are a series of different sieves with different size fractions in. So here we've got an 8mm sieve. Here we'll have the 4mm, then we've got the 2, the 1, and this is according to the Wentworth scale. Okay, so you just simply place your sediment over the top, and then you shake it, and then you basically, anything that's retained in this top section, so I'll just quickly push some of this sediment through to speed up on the sieving. You can see that the sand goes through and it just leaves this sort of larger gravel fraction in the upper section. Okay, so we can then take that one off there, shake it through, make sure all the sand goes through. Yeah, and then we can weigh this sieve here to work out what the percentage by weight is of that fraction. And then we'll do the same with the next one and the next one and the next one. Okay, you'll see this data in your Excel tables. Here we've got the upper fraction of the sediment. So this is anything that was held in the 8mm sieve. And then all we can do is we can empty it out. Usually we would do this dry and completely cleared. You can see there's a little bit of sand on there, but usually we take that off. We'll weigh it, and then we know what the weight of that fraction of the sediment is. Okay. Okay. So once we've repeated that for all of the different size of the sieves, so we have the fraction, the weight fraction for each one of those for this site, we will then repeat that in the mid tide zone, and then we'll do it in the upper intertidal zone. Okay, so we'll have 3 sets of data, and we'll be able to work out what the difference is. Is there any sand in this section? We've already found there is. Is there any sand in the midsection? Is there any sand in the upper section? And what those different size fractions are, and how that variation is. Okay, another thing that we can look at is to identify whether our sediments are well sorted. Okay, so here, if we have a look on the floor, we can see that we've got some of these very large clasts, and then we've also got quite a bit of sand. So this is very poorly sorted sediment. Okay, that usually means it's in quite an energetic zone. If you have a look further up there, you'll see that actually the bulk of the sediment is more in this size fraction. Okay, so this would mean that they're more or less all the same size, and that is well sorted sediments. We can also look at, do we have an angular sediment? Are there lots of angles on it, or is it quite well rounded? Well, this is quite well rounded. That usually means that all of those edges have been taken off it. That usually means it's quite an energetic environment. Okay, and you'll see that from the sorting chart that I've got in the handout. On top of the size and the sorting and whether something is well angular, you've also got whether it is well rounded. So you can see here, this is obviously not round, it's not a sphere, it's more elongated, so the length is much larger than the width here. This one here is more rounded, so you can see it's closer to, so the length is similar to the width, but actually the bulk of these sediments are much longer than they are wide. Okay, so these would not be spherical. This is the sphericity, the roundness of the sediments. So as you will have seen in your video on Student Central, we have here the dumpy level and then we have the stave. Okay, so this is really important for identifying changes in elevation as you go up the beach, and from that you can actually plot the beach profile. That will give you some information as to what are the principal factors that are influencing the geomorphology of the beach. Okay, so here we've got our dumpy level right at the bottom of the beach, and we will be measuring our distance up the beach. Okay, so there are several ways you can do that. You can either use the upper and lower stadia as explained in the video, or we can very simply measure the distance between this point and that point, and then we can also look to see what the elevation is. So here you can see there's a series of measurements on the stave. Okay, so there you can see round about where Magda's hand is, that's probably about level with the elevation that we've got here, and that will tell you that we're at about metre and 20 centimetres there. Okay, then we can measure further up, and as you see, as she goes up the beach, the profile will actually get lower, so we'll be at say 90 centimetres, etc. Then once we get to a point where we can no longer see the stave, because obviously here we've got 7 metre tide and the stave's not that long, we can then move our dumpy level further up and then start again. Okay, but we use that as our 0 point. Now the data that I've given you will actually have all of that corrected. Okay, so all you will simply have to do is go, this will be your 0 level, then working your way up with distance, and you'll be able to plot the beach profile on Excel. Okay.